Okay, questions on 2.7. Number 19 was not one of your homework problems, but let's do it. It's an extra example, so you can add it on because it tells us something. Oh, now I gotta remember, what were we supposed to do on that one? Oh, okay. On this one, we were asked to find the equation for the inverse. So you remember that f of x means the same thing as y equals x plus 2 cubed. Remember, I gave you a process to find the inverse. You replace x with y and y with x, and then solve again for y. So that means x equals y plus 2 cubed. How do I get y out from under a parentheses where it's cubed?
You take the cube root.
You got it. Take the cube root of both sides. And then the cube root will cancel out the cube. So here's where we are. The cube root of x equals just y plus 2.
You subtract 2.
And then when we subtract 2, here's where you have to be careful. This minus 2 is not part of the radical, so don't make it look like it is. The cube root of x, then minus 2, completely separate from the radical, equals y. Now that we have solved for y, that represents f inverse of x. F inverse of x is the cube root of x minus 2. Now then the rest of this problem, so this problem had two parts to it. Actually 3 parts. It said, find an equation for the inverse. We did it. Here's the original function. It was given to us. Remember, inverse functions kind of undo each other. So here's one way we could verify. If I said, what if x equals 6? 6 plus 2, now let me pick a small number. What if x equals 1? 1 plus 2 is 3. What is 3 to the third? 3 times 27. Now what if I put 27 in here? What's the cube root of 27? 3 minus 2, 1. So we started with 1. It spit out 27. Then we put in 27, and it'll spit back 1. It'll output 1 for us again. So we know these are inverses, but if we follow the rules that are given, here's the way you really are officially supposed to verify that two functions are inverses. Compose them both directions, and you should get f of g of x equals x, and also g of f of x equals x. So we're going to do that both ways. If you do f with f inverse dropped in, that will mean f with the cube root of x minus 2 as the input. And then what's the rule for f? The rule for f is whatever the input is, you'll do the input plus 2 cubed. So if we input all of this, it's going to be the cube root of x minus 2, and then add 2, and cube it all. You're okay, Carly? The rule for f says whatever your input is, add 2 to it, and then cube it all. So this was my input. I added 2 to it, then I cubed it all.
Oh, I got you now.
So then, minus 2 plus 2 is gone. So the cube root of x cubed, what happens when you cube a cube root? It's just x. If two functions are inverses, you should be able to compose them both directions and get x both times. So we're halfway there.
Am I supposed to always get x?
Yes. If you do f inverse of f of x, then that means do f inverse with f dropped in. F is x plus 2 cubed. So then, what does f inverse do? The rule for f inverse, it says whatever your input is, do the cube root of the input, and then subtract 2 off the end. So cube root of whatever your input is, and then subtract 2 off the end. Well, if the input is x plus 2 cubed, and then you subtract 2 off of the end, What's the cube root of x plus 2 cubed? The cube root cancels out the cube, we just have x plus 2. Then subtract 2 on the end, and we landed on x. So in this case, f inverse of f of x equals x. So the thing that we found right here, we just verified it. It really is the correct inverse. Okay? And that's really what they were asking you to do on all of these 19 through 27. I'm going to tell you, did you get it? Thank you.
I put it on your curriculum.
Perfect, thanks. 27 is kind of a hard one. So I want to give you a quiz problem like number 27 and ask you to verify it. Actually, if we had more time, we'd work through it, but we're pushed for time, so we're not going to today. We might come back to it another time. But I do want you to be able to find the inverse, because I might give you one like this and say find the inverse. So how do you do it? You start out recognizing that f of x means the same thing as y. In order to find the equation of the inverse, you replace x with y and y with x and solve again for y. So that means x equals 2y plus 1 divided by y minus 3. Then we would want to clear the fractions out. So if we multiplied both sides by the common denominator, then we would have y minus 3 times x equals 2y plus 1, because the y minus 3's would cancel. And over here we'd have a y minus 3. So then, let's go ahead, and notice we got a y on the left and a y on the right, and we got to solve for y. If we distribute, we'll have xy minus 3x equals 2y plus 1. X is on the left, x is on the right. Whenever that happens, I'm sorry, x's, I'm saying x's. Y's. We're trying to solve for y. We got y's on both sides. We need them all on one side. So let's add 3x to both sides. Then that just leaves me xy equals 2y plus 1 plus 3x. I need all y's on the same side. So subtract 2y from both sides. That means xy minus 2y equals just 1 plus 3x. Now here's a trick you need to know. If you're trying to solve for y and it shows up in two places, y'all remember? I think we've talked about it before. Factor it out. So y is common to both terms. If you factor out y times x minus 2 equals 1 plus 3x. Now can you do it? How do you solve for y? Talk to me.
You divide by x minus 2.
There you go. You divide both sides by x minus 2. Remember, now you can cancel and you have y all by itself, and that y that's all by itself represents the inverse. F inverse of x equals 1 plus 3x over x minus 2. I'm not going to make you verify this one because it's kind of tedious. On another day we might do it. Okay, but I do want you to be able to find an inverse if I give you something like this. Okay, 42. Let's talk about this one. 42 asks you to do three things. It asks you to find an equation for the inverse, and then graph the original equation and the inverse. So I'm kind of going to do these out of order. Let's graph this original equation first. This is a little practice, a little review for your 2.5 redo quiz. If you graph it, you know it's going to be kin to your parent graph, y equals x squared, which you should have points memorized, 0, 0, 1, 1, negative 2, 4, positive 2, 4. So if you take your parent graph, what's this minus 1 going to do to it?
Left.
It's on the outside, it's not in parentheses, it doesn't affect the x's, it affects the y's, so that does down 1. Okay, so here's a list. I'm going to just make a list of ordered pairs on your parent graph. 0, 0. If I move it down 1, it's like subtracting 1 from the y's, so that'll make it 0, negative 1. 1, 1 on the parent graph. If I move it down 1, that turns into 1, 0. 2, 4 is on the parent graph. If I move it down 1, that's like subtracting 1 from the y's, that makes it 2, 3. If we do negative 1, 1, and subtract 1, that'll make it negative 1, 0. And negative 2, 4, subtract 1, that'll make it negative 2, 3. So, graph that. And where do I want this? Is it right here?
Heck yes, I did that right.
You did it right? Yay. So, 0, negative 1, 1, 0, 2, 1, 2, 3, negative 1, 0, and negative 2, 1, 2, 3. And so here's what the graph looks like. Except, I'm about to erase part of this, so I hope you did yours in pencil. Because the rest of this problem says we only want x values less than 0. So over here where any of my x values are bigger than 0, I'm not going to include those. I'm going to erase this part of the graph. Because this said, graph this function only for x values that are less than 0. So this one is 0, negative 1, and negative 1, 0, and negative 2, 3. Okay? So this is a graph of f of x, the original function. It's a graph of the original function for only negative x values. Now we're going to go back to part A. Part A said write an equation for the inverse. So y equals x squared minus 1 is the original. Replace x with y and y with x. So x equals y squared minus 1. Solve for y. Add 1 to both sides. X plus 1 equals y squared. Now what?
Square root of each.
You got it. Square root of both sides. Square root of x plus 1 equals square root of y squared. The square root undoes the square. So the square root of x plus 1 equals y. So now, that is the inverse equation. F inverse of x equals square root of x plus 1. It's really plus or minus, but we're not going to consider all of it. So we'll just leave it as the square root of x plus 1 for a moment. Now, what if I need to graph it? The easiest way to graph this is, what do I know about ordered pairs on the inverse function? Negative 2, 3 is going to show up on the inverse as 3, negative 2. Negative 1, 0 is going to show up on the inverse graph as 0, 1, 0, negative 1. And 0, negative 1 is going to show up as negative 1, 0. I'm going to do this in a different color. Let's graph all of the reverse points. So we're going to graph 3, negative 2. So there's 1, 2, 3, negative 2. And then we're going to graph 0, negative 1. 0, negative 1 is right there. And we're going to graph negative 1, 0 is right there. So the inverse function is in pink, and it's kind of got a little bit of overlap with the original function.
Well, I did half of it right.
You did half of it right? Now, I need to come back to this in a minute. Anytime you take the square root, what are you supposed to do?
Plus or minus.
Plus or minus. Which part did we end up with? Because if you graph a square root function, the normal square root function looks like this. Our square root function is reflected. So instead of, we didn't graph both of them, the plus and the minus, we only needed the minus because we restricted our domain up here. So there's an equation for the inverse. Now let's talk about the last thing. The last thing says